Hi guys. This section 6.6, fitting a quadratic model to data, is very similar to some things that we did earlier this year, especially linear regression models. And I think it'll be mostly a review and then a little new concept on systems. But other than that, I think this will be a pretty easy section for you. So let's go ahead and get started. What we're going to be doing is we're going to explore data sets that can be described either exactly or approximately by quadratic functions. So those are things that the x squared. We're going to fit a quadratic model to these data points so that we can use that model to make predictions of our data. And we're going to talk about some of the connections in later slides. Okay, skills that you're going to need to remember. Linear regression, this is a calculator skill. TI-84 people, this is whenever you did the stat calculate command. You went stat, and then first we edited our list, edit, and then we L1, and then we went to stat calculate linear regression. Okay. TI inspire people. What we did was we created a new document, and trying to remember this new document, and then we went to, I think, spreadsheets, and then we entered in our data sets there, and then we went to data and statistics. We added a new page, and we added data and statistics, and then we set up our graph so that the appropriate data set was on the x and y axis, and then we went to, I think it was under a menu command for linear regression. Okay, very similar today. We need to remember how to fit a linear function to data by picking 2 points, and we use the y minus y1 equals mx minus x1, our point slope formula. Okay, and you need to remember how to solve systems of equations. So a lot of old skills are coming to play today. These are kind of lessons I like because it really brings things together. Some data that fits a quadratic model. Well, this is all messed up here. Let's move this. Oh, can't. They're all together. This f of x is supposed to be over here. What does the above heading mean? When you graph the below listed data, it will make a parabola and have a general equation. Some data that fits a quadratic model. So if I have data, and when I plot it, it kind of looks like it is a parabola, then it's going to have this general equation, f of x equals ax squared plus bx plus c. And we're going to try to figure out what a, b, and c are so that it's the best fitting parabola that we could possibly have. These are the types of applications that will have this type of model. Area, because that unit is squared. Acceleration, deceleration, lots of physics applications here, because physics is always dealing with acceleration and stuff. And number of connections, examples are diagonals and a polygon. That comes into electricity, stuff like that. Okay? So a lot of applications today. When we're looking at data that fits a quadratic model that looks like it's part of a parabola or an entire parabola. Remember, how many points are there between, if I have 2 points, we know that there's exactly one line that connects them, right? Well, this is something you might not know. If I have 3 non-collinear points, yes, I could make a triangle, but I could also make a parabola, and it's really kind of hard to fit this. Oh, that's pretty good. Okay, maybe like this. If there are 3 non-collinear points, there's one quadratic function or one, that looks like I crossed that out, parabola that will contain them. Okay, and here's how this came to be, and I'm going to butcher some of these names here. This goes all the way back to this asteroid here. What is it, Ceres, I think? Okay, I think you learned about that in mythology. This guy, Piazzi, found it, and then they lost it. They couldn't find it again. But they did know that if it went around the sun, its orbit had to be an ellipse because it's stuff they've already figured out. Okay, and 5 points determined an ellipse. They also knew this much from math studies done previously. It was determined that Ceres had been seen and noted by others. So some other people found it, and they knew whose spot it was. This Piazzi guy knew a spot it was. So they found all these people who found these spots. They had these 5 data points. And then they're going to do things similar to what we did today. They found an ellipse, a formula for an ellipse where it would have to travel. and then they could search for it by using estimation, and then they were able to find it again. Okay. In the process of tackling this problem, Gauss, the greatest mathematician of his time, discovered a fundamental use of normal distribution. This is a statistical study that if you're interested in stats, you can take this. And this is why sometimes normal distribution is sometimes called Gaussian distribution. And basically, normal distribution is your bell-shaped curve. Okay? But basically, what you're talking about here is, orbits are humongous. And 5 people saw this asteroid, and they knew the exact location from their microscope or telescope or whatever it is, and then they were able to determine an equation, so they were able to find it. And think how big the sky is. That's a pretty remarkable thing. Okay, but that's just in case you like history. There's some math history classes you can take in college. I'm sure some of you will, and then you can email me and tell me how awesome it was. Okay, here are the steps to finding a quadratic equation to fit 3 points. So they're going to give us 3 points, and we're going to find that equation, y equals ax squared plus bx plus c. I want you to write this down. Basically, what you're going to do is you're going to plug these 3 xy points into this equation. So you're going to get something like 2 equals, like 1a plus b plus c. You're going to get a system of 3 equations with 3 unknowns. A, b, and c are going to be in all 3 of these. So maybe you get 8 equals 2a plus 2, it'll be 4a, I guess, plus 2b plus c, and maybe 16 equals, I'm just totally making this up, okay? All right, so you're going to get these 3 equations with a, b, and c. Then we are going to use those methods we talked about earlier this year. I think a lot of you will want to use the matrix. If you remember how to do this. Some of you might use elimination. And people with a TI Inspire, we didn't talk about this, but your TI Inspires can actually solve these. And if you remind me in class, I will show you the exact keystrokes because I don't recall. Or you can do a quick YouTube search and they will help you through that. But they can solve these also. Okay, we are going to do an example together and this will all make sense to you. But here are the steps you do want to copy in your notes. When asked for quadratic regression, you're going to use your calculator. Just like linear regression, but not linear, you're going to select the quadratic regression model. The keystrokes are the exact same, okay? Except when you do stat calculate, TI-84 people, stat calculate, you're going to select quadratic regression. TI Inspire people, same thing. When you do that last menu command, you're going to just select the quadratic regression. I might say quadratic model. I don't remember what it says exactly. Okay? Ask me any questions about your calculators in class when I see you next. But we're going to do this one by hand. Okay? Use both methods of fitting a quadratic model to find these points. Okay. So I have xy, xy, xy. We are plugging that into this guy. Y equals ax squared plus bx plus c. Okay? So 8 equals... x is -1, so this is going to be 1a, because -1 squared is 1, so 1a, minus b plus c. I just plugged in -1 here and here. Okay, next one, I'm going to plug 2 in for y. 2 equals 1 in for x, a, 1 in for x, plus b, plus c. And the last one, 4 in for y. 3 in, so it's 9a plus 3b plus c. All right. We can use our graphing calculators if you want. I think a lot of you would like that method best. So let's make our coefficient matrix first. 1, -1, 1, 1, 1, 1, 9, 3, 1. We're looking for a, b, and c equals 8, 2, 4. Go ahead and enter this guy in as A, this guy in as B. We're trying to get A, B, C by itself, so we take A inverse on the left, and we get A, B, C equals, I'm going to pause this while I type this in. I got 1, -3, 4. Okay, so the model that will represent these points, if I plotted these points and I graph this curve, y equals a is 1, so that's just x squared. B is -3, -3x plus 4. If I graph this guy, I will get the parabola that passes through these points. Okay, the other way you can do it is by that L1, enter those for x, x, x under L1. L2, enter 8, 2, and 4. And you can do the stat, calculate quadratic regression. You should get the same equation. Okay, so check that out, and if there's any problems with that, you're going to ask me that tomorrow. And find the right curve. So that's your notes for this section, and I wish you good luck on your homework.